Hello everyone. So in this video, I will demonstrate image processing by using Matlab program. So basically, we are going to try to check the concentration of porosity of photo. So in this case, I'm using SEM photo, which is scanning electron microscope. So let's start. So new script. So first of all, we will we have the code to open the photo itself. So we run. So we title it processing. So basically, this photo, this code only to get the photo, so we can actually use the manual. I mean, we can just open the file, but to save our time, so we will use the code. And uh, next we are making crop code so that we can choose uh, which part of the photo that we want to see the porosity. So basically, this is just a crop feature from the Matlab. So let's say we want to check in this part, so we double click, so we get crop photo. Next, basically, we will make the photo as an array. So basically, in Matlab, the photo consists of uh, integers between 0 to 1 and 55. So basically 0 is the dark, and 255 it's the bright. So basically we convert the photo array into an assigned array of uh, uh, an assigned array. So this is an assigned array. Highest integer. Then we will, after that, we will compare the photo, uh, the original photo, and photo and the photo and which the contrast has been converted. So this is so let's try first what happened here. So this is the original photo, and then we crop which part we want to check the porosity, and then double click. So the crop, and so in this photo, as you can see here, the contrast already been changed from the original one. It become brighter. Then we are inputting waiting for the to set the threshold here. So it's okay. Then do some repetition by Matlab itself, so that this step we are trying to convert the high contrast photo into the black and white, so that the Matlab can easily interpret which, I mean, the concentration of the porosity of the photo. So let's try. So try this. Then let's try to check in this side. Double click. Then we set the threshold. It's basically so Matlab will do repetition from threshold 175 until 210. So as you can see here, the Matlab run the program here so that you can check the concentration of porosity of the SEM photo. So here, let's compare our final photo, our previous photo. So yes, as you can see in this photo, so the Matlab interpret that in this part, because it has high contrast, it considered it as a porosity, and in this also. But basically, it's still hard for us to interpret the porosity concentration. So we are trying to have we'll try to convert the photo into a graph here. So this will help us to interpret the photo, to interpret the concentration of porosity in this photo. So it's easier for us to see the graph. As you can see here, this is the graph of the concentration of porosity of the SEM photo uh, that we have used. So the X label will be the threshold, then Y label will be porosity, it will be in percentage. So as you can see, the graph there, there is a spike here. So from this threshold, from this spike. So we actually avoid the spike before and after each point. So and we are taking the more stable uh, location of the graph, because uh, the spike in this graph indicates that the value is not stable. Uh, However, we want to have a stable uh, data, so we we consider this as a stable. So from this line on to this line, so this is the stable uh, data of the graph. So based on this graph, the concentration of the photo, when the concentration of porosity of the SEM photo lies between uh, the threshold of 187 and 200, and the concentration of porosity range between 0.1367% up to 0.165. So as you can see here, it is easier for us to interpret the data by using I mean, it's easier for us to interpret the concentration of porosity by using graph. So let's see the photo once again. So actually, if in visual we cannot really say whether this is porosity or not, but this graph talks a lot. So we are, and in this graph we are taking the data be after the spike and before the spike, because the spike graph indicates the unstable value from the image. So the spike from the graph is considered as not valid. So we have to avoid the data before I mean, uh, we have to avoid this data and this data, and then we consider this as a stable uh, value from the image. So let's try another case here. Let's run again. So we are using a much more easier. So let's try same value threshold. So in this graph, the spike lies between the threshold of 175 up to 190. So that is the highest spike in this uh, graph. So basically, it's quite after that it is quite stable graph here until 210. So as you can see here, the concentration of the porosity is the 1.4 up to 1. So you can see here it's because from the image itself the hole is bigger, so that's why the concentration of porosity is higher than the last photo. So let's compare. Let's see our actual photo here. So as you can see here, this is the porosity, and porosity. So this is the image that the contrast has been converted from the grayscale into the high contrast photo, and then we converted into the black and white, and then this is the graph. So from the graph we take the data after the spike, and basically it's quite stable after this, after the spike itself. So the result between this photo and the SEM photo should be different, because in SEM photo, if we see once again, this is the photo is 550 millimicron, and it's already been zoomed by the scanning electron microscope up to 1,500 times. So the concentration of the porosity is already small compared to the wealth image that we have here. Okay, so basically this program, this code is trying to check the concentration of the porosity of an image by changing the type of image. We convert that into the high contrast photo, and then after that we convert that into black and white photo, so that we can the Matlab can show which interpret. The Matlab can show which part of the image that has porosity. So I think that's all for the demonstration. Thank you.